All right, so today we're actually just going to recap graphing and using exponential growth and decay functions again. I feel like we need some more practice with this, just getting used to our shapes. With all the snow, it's been hard for us to stay on pace, so we're going to be working on these again just to make sure we really understand them. So we're going to be graphing these. If you remember, the first step here is to plot the asymptote, which is right there. It follows our y movement, so we're going to go up 2. Now notice the scale is 2. Now asymptotes make a line that our graph cannot pass. Next we're going to make an xy table of here. That says +1, so I'm going to do opposite and do -1. Then we're going to do 1 below and 1, or 1 above and 1 below. Then we're going to substitute these numbers in. Again, I'm going to put them into x, so I'll put 0 in. And my calculator, it's going to look just like this. And I'm going to enter, and it's going to give me a value. It'll give me 3. When I put -1 in, it's going to give me, wait, this will be, I made a mistake. This will be a 2. So then this is going to change to a 4. And then when I put a -1 in, I'm going to get 3. When I put -2 in, I'm going to get 1. And so, no, sorry, -2 will be 2.5. I apologize. I went and checked that. So when I put -2 in, I'm going to get 2.5. So we got 0, 4, which would be right there because it counts by 2's. -1, 3, which would be right in the center, and then -2, 2.5. Then we have the graph that's formed right there. It is a growth function because this is larger than 1. Our domain and range, so domain is all real numbers, and I could write that on all of these. And then range is going to be the asymptote, so +2 to infinity. And we're done. The next graph, I'm going to go a little faster here, so -3 is the asymptote. And then we're going to make a table of values, so x, y. This number we're going to switch. We're going to go 1 above, 1 below. Then we're going to put these numbers in and get numbers out. So when we do that, we're going to get some interesting things. So that will be 0. Let's see here, 3, 0, yep. And then 1 would be -2 and 2/3. Let me double check my math real quick. Yes. So then 1 is -2 and 2/3, which will be like right there, right above the line. 2 and -2, and then 3 and 0. And then we can draw the shape of our graph here. And that's not perfect, but that's okay. And that's our shape, and then the domain is all real numbers. The range is, again, it stops at the asymptote, which is -3, and then this is infinity. So this is the only number it comes from right there. These ones are decay, so similar process, +3 is our asymptote. I forgot to do it in green. Yeah, let's do it all in blue now. We do an xy table. This is a -2, so we're going to write +2. It'll be opposite. We're going to do 1 above and 1 below. So I'm going to put a number in, get a number out. So when I put a 2 in, I get 4. When I put a 1 in, I'm going to get 6. When I put a 3 in, I'm going to get 3 1/3. So let's see here, 1, 6, so that's 4, 6. And then 2 is 4, and then 3 is 3 1/3. So right there, then we can draw a shape here. Next, we're going to do domain and range. It's the same process as before, so domain is all real numbers, always for these shapes. Range is our asymptote, which is 3 to infinity. Our next one here, we have a xy table and our invisible asymptote here at -3. We're going to write +4, and we're going to go up and down 1. So let's do that correctly. So up 1 and down 1. When I put 4 in, I'm going to get -2. When I put 5 in, I'm going to get -2.5. When I put 3 in, I'm going to get -1. And so we could do this 3, -1, 4, -2, and then 5 right there. Kind of a small dots on the scale. There's our graph. The domain is all real numbers. The range is your asymptote right there with infinity. All right, number 10. So this is actually a real life situation. I actually looked this up online. You can actually invest in I-bonds right now at that rate. So if you invest $5,000 for 5 years, compounded quarterly, how much money do you have at the end of the 5 years? So the formula we're going to use is this one that we talked about in class. Then we're going to put all these numbers in. So 5,000 is our starting value. 1 plus our rate as a decimal. Quarterly means 4. And then time is 5 years. Then we're going to put that in the calculator. Remember to put it in bright, so it'll look like this. 5,000 power, no powers yet, sorry. 5,000 parenthesis 1 plus parenthesis 0.0258 divided by 4. 2 parentheses power 4 times 5 in parentheses. That's how it's going to look. So we're going to put that in the calculator here. All right, let's turn this on. Let's put this in. So 5,000 parenthesis 1 plus parenthesis 0.0258 divided by 4, close parenthesis, another parenthesis, power button, parenthesis, 4 times 5, enter. So then we'll have $5,686.09. So you can see that we made $686 in 5 years. So yeah, that's it. Now, this is another real-life situation. So the Windsor 2 is a part of a mutual fund you can put your money in. And it's averaged 10.99% interest rate for the last 52 years. So you can actually look up that online if you're interested in investing already. If you invested $5,000 when the account opened, how much would you have now? So it's a little tricky, right? But we have the $5,000 is the P. 1 plus our rate, which is 0.1099, over 1, doesn't say anything, so it's 1. And then the number of years is when we invested at the beginning. So if we invested when this first started out, if we just got in when everyone else was getting in, when 50 years ago, let's say your grandparents signed you up for an account, right? That's the math. So we're going to put this in the calculator here, same $5,000, just different investment. Remember to put it in correctly here. So we have the amount with the parenthesis, with the 1 plus. The fraction is going to be in a parenthesis divided by 1. And then this will have 2 parentheses, power button, 1 times 52, close parenthesis, enter. And we would have $1 million. So 113 1697. And I forget the change, sorry. But yeah, we would be very wealthy. So just remember that about investments is a small amount over a large time will get us a lot of money. But a lot of us don't have a lot of money. So you can actually invest right now continually and make that same amount. All right. How much did you make? What if you invested double? So if you doubled this, then you double that. So if I times, so this would be times 2 if I doubled it. So I could make even more money the more I start out with. But again, it takes a whole lifetime to build a portfolio plan like this. So I advise, even if it's a couple $100 now, try just starting to save money in your savings account, and then when you get, because most places require like $5,000 in to get in, so you need to start saving money first before you can get in investment opportunities. All right, so we're going to do depreciation now. This is our formula, 1 minus the rate to the t, and we have a new fishing boat we just bought for $15,000. It depreciates at a rate of 8%, a little over 8%. So we're going to do this, and it'll be for 7 years. And so we're going to put that in the calculator. There's nothing hard about this, putting this in the calculator, just because there's no tricks to it. So we can actually just put this in 15, 1, 2, 3, parentheses 1 minus 0.086, parentheses, power button 7, enter, and then our boat was worth about $8,000, or $7,993.09. So $7,993.09. Okay, so I mean, if you caught a lot of fish, it was worth it, I guess. Or again, I mean, we make money to make life more enjoyable. So if that's the price of enjoyment, is only that much, then I guess that's a good deal. Number 13, you find a sweet deal on a Ford Mustang. You bought it for $21,956, while it's worth $32,000. So you basically got it for $10,000 less. It depreciates at 11.8% per year. How long can you drive it until it is worth the amount the money that you paid for it? So we can actually just we can put a formula together for this, but it won't make much sense because our answer we already have. We already have the answer. So we already have the answer. So we want to know this rate that we're subtracting. No, we already know the rate. It's 11. We just want to know this time, how many years. And so we could just guess and check, you know. So we could, you know, put 1 in or 2 in. So let's do that. Let's put 1 in. So 32,000, 1 minus 0.118, and then let's do 1 year. Okay, that wasn't enough. So maybe 2, 3 years. Let's do 3 years. So let's put this in here. And that is it. So 3 years. So if you're really savvy with some salesmen and you can get them to come down on the price enough, you could actually buy a car, drive it around for a while, and then resell it and lose no money. So if you had this car for 3 years, you would lose no money because you got it for a good deal. So that's a good way to save money, I guess. Number 14, at what interest rate do you need to make $40,000 a year off $650,000 investment? So this is a little tricky, right? Because we want to make $40,000. So that means our answer is going to be the sum of these, right? And then this is going to be the investment. And then we are going to have 1 minus our rate. Now n's going to be 1 here because we don't talk about it. And it says a year, so 1. So there's all these 1s here because we don't, you know, it's a year, so that's what we want. We want to know the rate that we need to get that. So there is a way to solve this. Yeah, we could actually just solve this. So we have 69000 minus 650,000, and then let's take all these 1s out. Right? So the power of 1 I don't need. Then we can divide off the 650. So all these zeros are going to cancel. So I'm just going to do right here. So 69 divided by 65 is 1.062. So 1.062. And that's going to cancel these. So I have a 1 minus r. Okay. Oh, this is supposed to be plus. Sorry, these are all pluses. That's depreciation. It'll never be that amount because of the rate. Yeah, it needs to be positive because we're growing. Now we're going to subtract 1. That's silly. So we get 0.062 is equal to r, or 6.2%. Okay, so you can make as much as a teacher without ever working if you have this much money saved in a 6.2% account. Is that possible? Well, I just told you ahead, right up here. The Windsor 2 has averaged 10.99% for the last 52 years. So it's very possible to make as much money as a teacher